Welcome to video lesson number 2, Dimensional Analysis Practice. The objective of this lesson is to practice using conversion factors and to do some more challenging dimensional analysis problems together. Please pause this video at the suggested places so that you can practice and then check your answers with me. I'm going to share my screen now as we go into working some of the problems together. The first problem we're going to do, practice problem number 2 from our notes packet, is the following. What is the density of sugar in grams per cubic centimeter if its density is 1,590 kilograms per cubic meter? So as with any dimensional analysis problem, the first step is to write down the number we're starting with. So from the problem, there's only one number, 1,590 kilograms per cubic meter. Now please pause this video and go ahead and convert your numerator to grams. So what conversion factor can you use to go from kilograms to... So once you've converted your numerator and canceled your units, we're ready to work with the denominator. Now we're starting with cubic meters, and we want our denominator to eventually be grams per cubic centimeter. So you're looking for a relationship between meters and centimeters. And we know from our metric conversion that there's 100 centimeters in 1 meter. So I'm going to start by using that conversion factor. 100 centimeters in 1 meter. Now you can see that meters and meters cubed are not going to cancel with each other. They're not the same unit. So in order to get meters cubed to cancel, I'm going to use this conversion 3 times. Meters times meters times meters. Okay, so it's the same conversion factor used 3 times. If you're going to cube the unit, you have to cube the numerical factor that's associated with it as well. Now I'm ready to take meters cubed and cancel it. So now you're going to pause the video and you're going to do this calculation and round to the correct number of sig figs. Then you'll be checking your answer with me. Now check your answer. It should be 1.59 grams per cubic centimeter. The way you would solve this on your calculator is 1,590 times 1,000 divided by 100, divided by 100, divided by 100. We have only 3 sig figs here in our number that we started with, so we're going to end up with 3 sig figs in our answer. All these conversion factors are definitions in the metric system, and therefore they have an infinite number of sig figs and do not determine anything about our answer. So the last problem and the problems coming up are using dimensional analysis in a way where we have 2- and 3-dimensional conversion factors, like the cubing that we saw in the last problem. So let's take a look at another example. You're given a blue liquid and you determine its mass to be 6.48 times 10 to the 4 milligrams and the volume to be 54 cubic centimeters. what is the density of the liquid in grams per cubic centimeter? Okay, so we are looking for an answer where grams are in the numerator and cubic centimeters are in the denominator. So we are going to start with the numbers given. So the 6.48 milligrams, which is my mass, and the volume of 54 cubic centimeters, which is my volume. That's going to go in the denominator if I'm trying to solve for a density. So I'm going to start with those numbers. 6.48 times 10 to the 4 milligrams over 54.0 cubic centimeters. So great news, we already have cubic centimeters in our denominator. So the only thing we need to convert for this problem is milligrams, and we want to turn those into grams. So pause the video now, and using the information that you know about metric conversions, put in a conversion factor that will turn milligrams into grams. So this should be the conversion factor that you came up with. There are 1,000 milligrams in a gram. So we have milligrams canceling. And then on your calculator, 6.48 times 10 to the 4th. Remember, you can type this in as 6.48 E4. Remember, the capital E stands for times 10 to the, divided by 54, divided by 1,000. So the answer we should get for this is 1.20 grams per cubic centimeter. Our three sig figs come from both the values for mass and volume that we started with. Okay, so this was a fairly, I call this dimensional analysis for beginners, kind of, because we only have like a one-step problem. Now, in part B, we're going to take this liquid and express it in kilograms per cubic meter. Okay, so you can start with this number, 1.20, because that's the density that we calculated in the previous step. So 1.20 grams per cubic centimeter. And then we need to use conversion factors to get to kilograms per cubic meter. So you want to pause the video now and turn your grams into kilograms. Now we have to take our cubic centimeters and then turn them into cubic meters. And if you remember in the first problem that we did today, we took advantage of what we know about the relationship between centimeters and meters. And we started to write conversion factors that would allow us to convert our cubic centimeters. So we know there are 100 centimeters in 1 meter. And to get to the cubic version of that, we need to use that conversion factor 3 times. Okay, now we're able to cancel cubic centimeters with cubic centimeters. Now, is it necessary to write this out 3 times, or could you write it once and put the whole quantity cubed? And the answer is, of course, you can write it that way. But when you go on your calculator, you have to remember that if you're cubing the quantity, you have to cube this number as well, 100 times 100 times 100. pause the video now and then check your answer with me. So the answer is 1,200 kilograms per cubic meter. And this line that I've put over this 0 here in the tens place is there to indicate that that is a significant digit, a sig fig. Okay, we can have 3 sig figs in our answer, and so the way that we can show that over here is to just put a little line over the 0. Alternatively, you could write this in scientific notation. So you could put 1.20 times 10 to the 3. Okay, that's another way of writing it, which shows that there are 3 sig figs in your answer. So one more problem of this type. The area of your desk is 2.53 times 10 to the 6 square millimeters. I'm not sure who would measure an area of a desk in a unit that small, but let's go with it. And we want to express this value in square meters. Now, sometimes when you're only given like one quantity in the problem, you'll see me put this whole thing over 1. Sometimes just for the appearance of the problem. It's not necessary to do that, but in some of my answer keys, you will see me do that. So I want to go to square meters. So what do I know about millimeters and meters? Okay, so we know from the metric system conversions that there are 1,000 millimeters in 1 meter. And of course, I need square millimeters, so I've got to do it one more time. 1,000 millimeters in 1 meter. Now my square meters are going to cancel, square millimeters are going to cancel. And on my calculator, I will do 2.53 EE6, okay, using your exponent key, your scientific notation key, divided by 1,000, divided by 1,000. All those numbers go into the calculator. Okay, pause now to make sure you can do that calculation. And your answer should come out to 2.53 square meters. That's a pretty big desk, actually.